Welcome to aminacademy.com. In chemistry, let us discuss about energy transfer and energy as a heat. Heat is the total energy of the motion of the molecules of your substance, whereas temperature refers to the measure of the average energy of the motion of the molecules in the substance. The heat is dependent on the factors like the speed of the particles, the size of the particles, and the number of particles. Here we know that heat is a energy. Our tremendous energy supplier for the earth is the sun. Sun is delivering heat energy to the earth millions and millions of joules per second. So it is a very important energy. From heat is the energy, from that energy is converted as different energies. We'll discuss that in later. Now we'll discuss about enthalpy. Look at this figure. Here a container have some liquid as a water, like we are giving heat. That heat is absorbed by the water and this temperature rises and that heat is released as a steam out. For that the temperature is increasing. That amount of heat supplied is something absorbed, something delivered. Some part of the heat is absorbed to raise the temperature and excess heat is released. The enthalpy is significant because it tells us how much heat is there in your system. That means energy system. Here heat is essential because it allows us to produce useful work. In this article, let us discuss about total enthalpy. Here that enthalpy is considered as a heat, energy, how it's stored and how it's produced as a useful work. What is enthalpy? The heat absorbed or released during a process at constant pressure is equal to the change in enthalpy. That means change in enthalpy is when the constant pressure is called heat absorbed as a work is released. Sometimes referred to as heat content. Enthalpy is a fascinating and uncommon word that most people prefer to use. According to its etymology, the words entropy or enthalpy are derivations of the Greek words turning or warming respectively. In terms of here, enthalpy H, capital H, is the sum of the internal energy U and the product of pressure and volume. Look at this, pressure and volume, that is PV, plus internal energy U, both added is H, that is enthalpy. Therefore H equal to U plus PV, where H equal to enthalpy of the system, U is the internal energy of the system, P is the pressure of the system, and V the volume of the system. The heat added or lost by the system is measured as the change in enthalpy. That means delta H is heat added or lost by the system, measured as the change in enthalpy, delta H. Enthalpy can also be written as delta H change in enthalpy equal change in internal energy plus change in P, pressure, into volume. At constant temperature, the heat flow Q for the process is equal to the change in enthalpy, which is expressed as delta H equal Q, that is heat flow. Here next, molar heat capacity. Molar heat capacity is defined as the amount of heat required to raise 1 mole of a substance by 1 degree Kelvin. Molar heat capacity is very similar to the specific heat capacity but measures per mole instead of per gram of a substance. Let us further discuss about heat energy. A sample of matter can transfer energy to another sample. Some examples of energy transfer are the electric current. That means electric current is produced by heating up coal or diesel, oil, and it turns the turbine and it generates electricity. That means this mechanical power is supplied to the electric generator and it's produced current. That is next heat, that is chemical energy of the petrol is used as a work mechanical energy in an engine. Though energy has many different forms, all energy is measured in units called joules. So the amount of energy that one sample transfers to another sample as heat is measured in joules. That means energy is actually transferred as a heat. Energy is never created nor destroyed. It's a universal rule. But it can change from one form to another. The amount of energy transferred from one sample must be equal to the amount of energy received by the second sample. Therefore, the total energy of the two samples remains exactly the same. When samples, we'll discuss about the temperature further. When samples of different temperature are in constant contact, energy is transferred from the sample that has the higher temperature to the sample that has the lower temperature. Normally, heat is flow from higher level to lower level. Therefore, the temperature we can describe as a measure of how hot or cold something is, specifically a measure of the average kinetic energy of the particle in an object. Here, the temperature increases of the of a sample also depends on the mass of the sample. For example, the liquids in two beakers were initially 10 degrees Celsius, for example, and equal quantities of energy were transferred to each beaker. The temperature increase in the beaker on the beaker is more when the amount of quantity of that is water is less. Means more quantity water needs more energy, so the temperature increase is less. Vice versa is there. Heat and temperature are different. We know that. You may notice that the heat and temperature are different because you know that when two samples at different temperature are in contact, energy can be transferred as heat. Heat and temperature differ in other ways. That is, temperature is an intensive property, which means that the temperature of a sample does not depend on the amount of the sample. However, heat is the extensive property, which means that the amount of energy transferred as heat by a sample depends on the amount of the sample. So, water in a glass and water in some other pot can have the same temperature, but the water in the other pot can transfer more energy as heat to another sample because the water in the pot has more particles than the water in the glass. That means conduction is more in pot than in glass. Or that we know that molar heat capacity, that is the molar heat capacity of a pure substance is the energy as heat needed to increase the temperature of 1 mole of the substance by 1 K. Now we will discuss the formula of molar heat capacity, that is Q equal N C delta T. Here Q equal to molar heat capacity, N is the number of moles of matter, C is the molar heat capacity, and delta T is the change in temperature. Here therefore heat, that is enthalpy, heat can be referred as the product of amount of moles. Amount of moles, amount in moles into molar heat capacity. C is the molar heat into change in temperature. Therefore, Q equal to heat is defined as the product of number of moles, amount of moles in the matter and molar heat capacity into change in temperature. So for further discussion, we will see in next videos. We have done. Please subscribe our YouTube channel.